It's recorded. Now the lecture is recorded. Please don't touch this button, all right? Remember, immediately today I unlock the lecture in YouTube. Don't forget to subscribe my YouTube channel. Remember, you have 5 extra points. See, I receive notification. I receive notification in my YouTube channel. However, I don't know why sometimes I do not receive notification. You remind me, Professor. Okay, you forgot my 5 extra points. Bueno, you see the overall grade in Blackboard. I want to post it as soon as possible. I suppose the next day we have already your grade and the test one. Okay. Let's move on to the whiteboard. I propose you do one more example of the circle. Please put the microphone on, off, everyone. Only activate when you want to ask me something. Or I prefer by chat. Okay. Okay. So we start. Yeah. Ready to pay attention? Okay. Let's do it one more. Let's do one more example of the circle. Remember, this is a typical example in the test. And the test is given the equation of the circle, but a non-standard. 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 Normally, a non-standard is called general. It doesn't matter. It's not important. It's just a name. Entonces, I need to determine the center. I need to determine the radius. And do the graph. Do the graph by hand or using Desmos. Either way. And the test, when you are doing graphic, this test number 2 is a little bit more complicated because we have a lot of graph. But we can do everything in Desmos if you want. Okay. Let me see the organization for this. The organization is you take X. I copy separately. Now I put a box. Inside the box, remember we have the magic number that completes the square, right? And you take now Y. Y squared plus 6Y plus box. Another completed square, 2 completed square for the X part, for the Y part. Now this 9, I move to the right hand side and we have 2 boxes. And these boxes is the same number that we have in the left hand side. I put in the right hand side in the left hand side in order to doesn't affect my equation. Okay. Somebody can help me with the first number? What is the first number here? 4. Very well. Where come from that 4? That 4 comes from 4 divided by 2 squared. Esa es la fórmula. 4 divided by 2 is 2, and 2 squared is 4. It's a coincidence. Pero no always is a coincidence. Now, you put artificially this 4 here. You put this 4 here. And what is the second number? Help me. Here. And that box. 9. Very well, Sabrina. 9 because 6 divided by 2 is square. 6 divided by 2 is 3, and 3 squared is 9. Entonces 9. Very well. 9. Wait. 9. Entonces you put 9 here. Oh, too much on the. Espérate. Well, okay. 4. 9. Another box. This is 4 and this is 9, huh? I did well. Okay, now I focus on my first trinomial. The factorization of this guy is x plus 2. Do you understand very well where come from these two? Square root 4 and x is square root x squared. And the second trinomial is y plus 3. By the same reason. 3 is square root 9 is 3 and square root y squared is y. In the right hand side, we have, wow, this is cancel, stay for. Okay, let me copy now my new equation, okay, by the way, is equivalent to the original, but now it's expressed in standard. Remember, the standard is something like that, x minus h squared plus y minus k squared equal r squared. This is the, in general. In particular, in our example is x plus 2 squared plus y plus 3 squared equal 4. So you can see clear that the center of this circle is located at the point negative 2 comma negative 3. Look, because h is negative 2. Remember, opposite sign, guy. See in the question you see plus is because it's minus. Because in the general we have minus. So what is the reason it's plus? It's the reason it's plus because h is negative 2 and double negative become positive. Like y here, well, in this case, negative 3. And the radius, you take that number, get 4, and you suppose that r squared is equal to 4. Therefore, r alone is square root 4 get 2. This is my radius. Okay? What is the last part of this question? Well, let's do in the graph. Let's do in the graph by hand. This is another class. Well, okay. Let's do in the graph here. And that part, I erased the entire board. Suppose by hand. X, Y. Okay, I plot the center. Negative 2, negative 3. Negative 1, negative 2. Negative 1, negative 2, negative 3. This is my center. This is this point. I know get radius 2, but 2 in any direction. We have infinity direction. But no. We take the fundamental. What is the fundamental? To up, to down, to right, to left. Okay, like that. North, south, east, and west. And that's it. It's enough. The 2 point here is here, to the right. Okay, this point, by the way, is the point 0, negative 3, no? This point, by the way, is the point minus 2, minus 3, gets the center. 2 up here. This point, by the way, is negative 2, negative 1, no? Because this is negative 1. 2 in the other direction, now is negative 4, like that. This point is the point negative 4, negative 3. You move it horizontal and the y component stay the same and the x component no, is decreasing by 2 because we move it to the left, and down is 1, 2 here. That point is the point negative 2, negative 5 because you're moving 2 units down and the y component 2 units. Now my circle approximately look like that. Wow, I do my best, but it's hard for me and my pen using. Okay, but we are doing this one more clear. Question. Do you understand very well where I come from this number? This point, this point, this point, this point, and this point? How do you determine the point? Okay, it's easy. For example, from the center, from the center, I want to determine this point. I know that you move up 2 units. Therefore, see the coordinate of this point is negative 2, negative 3, and you move it up. This x component stay the same. That is the reason I put negative 2, stay the same. However, negative 3 plus 2, y plus 2, because the radius 2, no? The radius 2, so you move it up, and up is plus, increasing. The negative 3 plus 2 is negative 1. And that is the reason I put negative 1. Got it? Got it? Likewise, or similarly, this point is going down. See, it's going down in subtraction. Entonces, es from this, que es negative 2, negative 3, It's going down, vertical speaking. Now this is -2. So it's -2, this stays the same, but -3 minus 2 is -5. Clear? And this is the motion is horizontal. So when the motion is horizontal, you increasing in that direction, increasing, or decreasing in that direction. But in this case, the x component. See, this point is the center, is located at the point, -2, -3, and you move into the right, you increasing the x component +2, and -2 plus 2 is 0. And -2 minus 2 is -4, que es that point. Make sense or clear? Or not clear? Clear or no? Come on, I need to know. Yes or no? Come on, answer me. It's clear. Okay. Just in case, let me check it out in Desmos. Okay, let me switch into Desmos. Screen, share screen to Desmos. There you go. Okay. You see Desmos? Let me put in the projector mode to see more clear. This is the last example. Look at the point. Look at the, I copy, look at that. I copy here. I copy the equation in non-standard, look, in orange color, and the equation in standard in green color. And you see that they are perfect coincidence. So the manipulation of the complete square technique is only accommodation our given equation in another way to visualize, to see more clear the parameters are center and radius. And the typical point, look at that, -3, let me make a zoom, exactly the same elegant circle. -2, -3 is the center. And the other point is -2, -1. Any question? Do you want another problem or no?
Yes.
Okay, let's do it another. Sabrina says yes. Okay, so, but the problem is, guys, our class is only 50 minutes. So I recommend no. I recommend is moving on to the next section. Okay, and remember we go over again to this in the review package, right? No, 50 minutes. 50 minutes is crazy. I don't know. I talked to you, the chairperson. You said try to do your best. Well, I try to do my best. Okay, let me erase the board. Okay, let me introduce a new topic, guy. New topic. Okay, new topic is about the function. Functions. So the name of the topic is functions and relations. Okay, function and relation. Let me try to understand this new concept, relation. Well, relation is super easy. Relation is association in between two sets. So you have two sets. Suppose capital X, professor, we can't see. Sorry. Sabrina, thank you. You are the best. Okay. Now you see? Okay. I say we study new topic is called function and relation. Let me try to explain first relation. Relation is very intuitive idea. It's an association between two sets. Suppose that we have two sets, capital X and capital Y. And the set is the collection of the object. Maybe number, maybe people, maybe subject, maybe letter. Okay, suppose I bring one example that maybe it's easy to understand. It's about one class I have, hypothetical class of course, the MAC1105. We have 4 students in the MAC1105. Actually, I have 39. The name of this guy is Sally, Paul, King, and Luis. Okay, this is my first set. Normally the first set is called domain. You need to be familiar with this name, guys. Domain is the set que corresponde with the first element. In this case, is students in college algebra. Entonces, when the college algebra is over, the last day, I need to associate, relate each student with the grade, corresponding grade. Entonces, according to the Miami-Dade College, any college, the typical grade is A, B, C, D, and F. Okay, so I need to associate each student with the grade. It's no infinity letter. O sea, letter E is no grade. It's no official grade, you know. It's A, B, C, D, and F. Well, W is possible. Okay, but don't worry. This is not important now. Now, what is the relation? Well, the relation is the association. So, for example, the symbolic way to indicate this idea is, for example, Sally is an excellent student, get A. Like that. So you put like an order pair. Sally, comma A. This is her grade of Sally. Okay. You write like an order pair. So the first component is the component associated with the domain, and the second is associated with the range. By the way, I forgot to say that the second set normally is called range. It's totally named range. Domain is the first, que represent the first component, and you express it like an ordered pair. Association, Sally, get A. Paul, I don't know, B. King, also B. And Luis is excellent student, get A. And this is the symbolic way to represent relation. Okay, in other few words, is association between two sets. It's important to understand that the order is important. So we have two sets, X and Y. X is the first. Now it's the reason it's called domain. And the second is range. Okay? What about function? This idea is clear, right? It's straightforward. You can state relationship between different sets. For example, when you go to the supermarket, you associate the price with the different items. So this is association, not only mathematics. Okay, suppose a function. Function is a special relation. Function is a special relation. The most important characteristic is a relation. It's a relation such that each value in domain, que es the first set, remember, is associated with only one, and this is the most important, only one is the most important part of the definition of the function, value in the range. Okay? But however, this definition is confusing. At least for me, it's confusing. Let me explain why it's confusing. Suppose that we have, for example, one associate like that, one relation like that, relation one. Well, no, first of all, let me define in this, okay, let me define who is a domain and who is a range. Domain is Let me see, my paper is number 1, 2, 3, 4. And range is letter A, B, C, and D. I want to state one relation in between this set. For example, relation 1. Relation 1 is, look at that. I associate 1 and A. I associate 2 and B. I associate 3 and C. I associate 4 and D. Okay, easy. My question is a function or no? According to the definition for the function. Remember, definition say each value in the domain. Of course, yes. It's obvious, yes, because you associate 1 and A, 2 and B, blah, blah, blah. However, let me see another case can maybe clarify a little bit. 2 more examples. For example, I want to associate 1 and A. I want to associate 2 and B. Repetition, the same idea. 3 and B. Now I select no C, I select B. Repetition, and 4 and A. Okay. Again, it's a function or no? So the answer for that question was yes. The answer for that question is, what do you think? They are contradiction with the definition for the function or no? What is your opinion? Yes or no?
Yes.
Yes, you are right. Yes, the reason is clear. Because 2 and 3, so this is clear, The maybe confusing part is 2 and 3 is associated with the 1B. And there are no contradiction with the definition for the function because the most important is that we have only one in the range. Okay. However, let's see what happened in the relation 3. In the relation 3, we have 1 and A. We have 2 and B. We have 2 and C. And we have 3 and D. Okay. It's a function or no?
No.
No. The reason is no, because you see that 2 is associated with the B and the C, and we have 2, no one, only 1. This is a contradiction with the definition of the function. Okay? Super clear? So we study relation and a specific relation get function. Okay, basically is. Okay, super, Sabrina. Okay, to continue with the same idea, I want to explain, suppose we have, not always we define the function in this way using set. For example, we have a function in the equation, no? Or in graphic. So identify the function when you have the graph. When the one graph is given, okay, it's identify the graph of the function. So one graph is given in the test, for example. I say you, please let me know if this graph corresponds with the function or not. I want to put different graph. Suppose like that, different graph. Suppose one graph like that. Suppose one graph like that. Remember, normally we put the arrow indicates us that this curve continue forever in that direction. Suppose this, and suppose maybe a circle. To determine to determine si this graph corresponds with the function. Yes, no, no, yes, no, no. You apply one thing, one test, important test, que is called vertical line test. Vertical line test. So you apply that test when you have the graph and you need to verification see as a function or no. And what consists this? When you are doing hypothetical vertical line like that. In any position, in any value. Like that, like that, like that, like that. See, cross in only one point. Look. So one line crossing in one point in on the curve. Here crossing only one, but here crossing two. And here crossing two. See, crossing only one is function. So this is function, yes. This is function, yes. This is not function, no. No. Why no? Why no? Let me explain why no. Because in this case, you associate students send me this. Interrupt me. Okay, suppose that we have x1, one pick one x1. I call x1. It's associated with two y. y1, y2. So x1 is associated with the y1 and y2. This is a contradiction for the function. No function. And here, no function. And this is a function. It's super easy to determine that. Everyone follow me, guys? Super clear or no? Sabrina is yes. Okay. This is a vertical line test. Keep in mind, we practice in the review package, okay? Okay, let's move on to next topic inside the function, no? Que es called a function notation. Function notation. Function notation is very convenient, very suitable representation for a function. What is the idea of function notation? Well, the function notation is, suppose that we have one equation, is y equal 4 minus x squared. However, I want to represent in different idea, different notation, using function notation. Instead of y, you put f of x. 4 minus x squared. And this allows us do, for example, transformation, representation in easy way. So this is function notation. Function notation is confusing because you assign one name of the function. This is a name. So in this case, f, you read like that, f of x. F is the name of the function. Normally, in mathematics, the name of the function is one letter, f, g, h, p, m of x, no? Always of x. Or you see in the other chart, the two letters, like lm of x, or three letters, l, g, x, and so on. In another sort, you may see trigonometric function, get sine, and so on. A three letter, two letter, or only one. The most popular in college algebra is one. Now, when you associate this convention, okay, by the way, guys, y and f of x is the same thing. But what is the convenient idea for expressing using notation? Well, okay, you can do transformation. And transformation we study in detail, I promise, next lecture. Suppose that I want to evaluate directly in 3. Okay, you say 4, you replace x for 3, 4 minus 3 squared, 4 minus 9, negative 5. Okay, we can do that in that way. But using numerical value, but you're using not only numerical value, you can use it, for example, x plus 3. Wow. Okay, x plus 3 inside the argument of the function is you replace.
How do you get to 3?
No, it's arbitrary value que I put here. Suppose que en el test I ask you, compute FN3 or compute FN5. This is a given. This is a given. This is one example I create. I don't know. I like 3. I don't know why. I repeat 3 here. Now, in this case, a combination variable and number. How you solve the problem? Well, exactly the same. You copy 4 minus x plus 3 squared. You leave it like that, you can. You leave it like that. However, much better, more elegant, you know, is expand that part as 4 minus. Entonces you FOIL this x plus 3 times itself is x squared plus 3x plus 3x plus 9, ¿no? Que es x squared plus 6x plus 9. Actually, the minus in front change complete the sign. Entonces, minus x squared minus 6x minus 9. Entonces, finally, we combine like term is minus x squared minus 6x minus 5. Okay? So the potential, the possibility que give me the function notation is do transformation. So inside the parenthesis, the element in the domain is the argument of the function. You put number and you put expression, and this expression represents something. Okay, I want to explain in detail next lecture. Okay, transformation. Okay, another typical transformation is reflection. Look, how we can do the reflection. The reflection is, suppose we come back again to the same example. F of x is easy, no complicated. 4 minus x squared. Suppose I want to make reflection. Reflection is you change x for negative x. This is reflection. Okay? I promise in next lecture I want to explain in detail the idea behind transformation. And one transformation is reflection. So I prepare for that moment, you replace x for negative x. I make a reflection. Well, minus x squared is positive. Wow. Okay, and this minus is this minus. And wow, those stay the same. This is a typical example in which you have a curve and you make a reflection and the curve or the function stay the same, doesn't change, it's the same. And this receives a special name, pero no now. Okay, reflection. So the thing I try to explain and you need to understand is the potential, the possibility to offer, bring me the function notation. We are doing transformation, you do something inside the parentheses, and we are doing several transformations. Maybe stretching, compressing, reflection, translation, rotation. Okay, but in this case, is reflection. Okay, another example of the function notation. Suppose I try to compute in the same function 2x. Wow, 2x. What is that? When you multiplication by 2, the argument, we are doing the stretch, right? Because it's multiplication, no? It's a stretch or it's compressed. I don't know exactly. We studied last time. But okay, the most important now is the how you manipulate that. So you copy forward, you replace x for 2x, so actually it's 2x squared. Leave it like that? No. It's 4 minus 2 squared is 4, x squared. Okay, and this is my new expression. Okay, okay, it's not the same of the origin. Okay, that means it's transformed. It's transformed. Okay, another possibility, interesting possibility of the function notation is determine the y-intercept and the x-intercept of any curve, any function, any curve. And so what is the formula? The student forgot. I don't remember very well what is the formula to find y-intercept and x-intercept. However, using function notation is super easy to memorize. This is like a mnemonic device. When you evaluate n0, you find y-intercept. And when you put a 0 in the y, you find the x-intercept. So this is easy. Let me do again in this elementary example. Again, we continue working with this function, que is 4 minus x squared. I want to determine y-intercept and after x-intercept in this specific function. So you evaluate 0. 4 minus 0 squared. Oh, it's 4. And the point is 0, 4. This is my y-intercept. Let's do in the graph just in case to see much better. To find the x-intercept, well, you take the function, because the function is, look, 4 minus x squared, and you enforce it to be 0. And in this moment, you have a quadratic equation, and you solve it. In this case, super easy solving using the square root method. That you move x squared to the right hand side, apply square root both sides. This is square root 4 plus or minus 2. Don't forget plus or minus 2 equal x. Therefore, we have 2 y-intercept at the point 2, 0 and at the point minus 2, 0. So you try to do the graph of this function. This function look like that. We have 2 important characteristic points, que is y-intercept de 4, 1, 2, 3, 4, 0, 4. And we have, this is on the y-axis, and we have 2 in the x-axis, que 2, 1, 2, 2, 0, and 1, 2, negative 2, 0. And this graph look like something like that. Okay? I bring another example. Of the similar to the y-intercept and x-intercept. Do you follow me, guy? Do you follow me? So good, Sabrina. Okay. Let me try another example. Let me try to illustrate another example of the y-intercept, x-intercept, because we are using throughout the course. Remember, we study a lot of functions in college algebra. In this function.
Can you go up a little bit?
Yeah. Another example, no? What do you say? Go a little bit.
Yeah, can you like there?
Okay. Let me know when you finish. You copy or no?
Yes, I'm copying it.
Okay, super. This is the lecturer's recorder. Nice. And the student don't change the background. Let's move on to another example to illustrate again the same idea. Look, suppose the function, let me change the name of the function, g of x is equal absolute value x plus 8. What is my goal? My goal is find y-intercept and x-intercept again. Okay, let's do it. I remember the mnemonic device, que is to find y-intercept, you evaluate the function n0. Let's do it. Absolute value 0 plus a. 0 plus a is a, y absolute value a is a. Okay. So the y-intercept is located at 8, and the point is 0, a. Remember the supposition was the x value is 0, and the y value is a. Que es given. To find the x-intercept, it's a little bit different. You take the function, using function notation, and you enforce it to be 0. In other words, it's absolute value x plus a. Equal to 0. Entonces in that moment we face one equation similar to the equation that we are doing in the test 1, que involve absolute value. But in absolute value, I know that we have only one solution, no? And you remove the bar. Therefore, x is minus a. Therefore, the point is the point minus a, comma 0, because the supposition was that y is 0, look at that, and x was negative. Entonces, ready. We are ready to do the graph of this. Okay, I suppose using my imagination. Remember, guys, absolute value function, the graph of the basic absolute value function, que es y equal absolute value function, look like that, the big. Look like the big. When the class is over, I want to send one document. In the document, you can see the most important basic function that we are using in college. Okay? Pero no. When the class is over, I send to you. Now, we plot the point. The first point is 0,8. I suppose 1, 2, 3, 4, 5, 6, 7, 8 here. Is the first point. Is the y-intercept on the y-axis. I plot the second point, is negative 8. 1, 2, 3, 4, 5, 6, 7, 8. Negative 8. Negative 8, comma 0 is the second point. I suppose that my graph look like that. Similar, the same shape of this. But is okay. It's the same B. I try to do my best. But it's moving. It's translated. There's a shift. In this case, shift to the left. A unit. Pero no. I promise que in the next lecture, we study in detail the idea for the transformation. Okay? Today, the only thing I want you understand is what is the convenience to using function notation to make a transformation, and also determine the y-intercept and x-intercept. This idea is clear or confusing? Clear or confusing? I know that you need more example, no? But I promise that in the review packet, we go over. It's confusing. What part confused, Sabrina? The intercept or in general? Okay. Trust to me. No. Okay. Sabrina is the X-Intercept professor. Okay. Let me summarize the idea. To find y-intercept. This is easy because it's just evaluate the function in 0. This is numerical, no equation. In X-Intercept, more complicated. Is you take the function, you enforce it to be 0. Now you have equation. And you solving this equation. Depending on the equation, no? Maybe it's a quadratic equation, absolute value equation, radical equation, but you solve the equation. And the x value, when you solve in this equation, represent the x-intercept. This is the key idea. Clear? Okay, guys. Let me try to spend the time, because we have not too much time, to explain another thing inside the function, definition. Okay, one typical question in the test is I provide you one graph. Look, let me try. Suppose I provide you in the test one graph. It's a given, the graph. And the graph look like that. Let me show you. Yeah, like that. Okay, we have the whole. And 2, is a 1, is a 3, This is given. This information is given. The thing is the interpretation of this. For and this arrow do not indicate direction. Indicate that this curve continue forever down, and this continue forever down. Let me see. That value is 1. Doesn't matter. This is given, and you accept that. And this value is 2, no? Okay, this is given. Given. And what is the question? The question is determine, look in the graph, no mathematics, only determine domain and range. Determine domain and determine range. Okay, let me explain in detail this. Remember, domain is, see, you define in your own word, what is domain? Domain is the set of X value such that the function is defined. The function is defined. Because we have two possibilities, define or undefined. So the symbolic way to indicate undefined, undefined means mistake, error, no associate any number, is we have, for example, we have a hole. This is a hole. Look at that. We have a hole here. We have another hole here. So the interpretation is that in this point, in 2, the function is undefined. You see que es 1, but actually it's no 1. Okay, no 1. Okay, this is to confuse you. 1. Entonces you say, no, professor, it's defined 1. No, 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 because it's a hole. So when you see a circle like that, open, is undefined. Because it's a hole. Undefined. It's a hole. Technical name is a hole. And when you see a circle like that, case closed or full, is defined. This is the notation that you need to understand graphically. In this case, define here, undefined here, undefined here. However, we have no value, and between 3 and 4, we have no value of the function. We have a gap. Here, a gap. And it's also undefined because we have no, suppose I want to evaluate the function in the middle, 3.5. We cannot find any value here, undefined. Okay, entonces, conclusion, domain. To find the domain, when the graph is given, my recommendation is, let me use in green color, you projecting any point on the curve, projecting onto the x-axis, because domain, remember, is x value. When you're projecting, I can see something like that. Ooh, here a hole, and 2 hole, and 3 no, and 3 bracket. Remember the idea for the inequality, parentheses do not include the endpoint, and bracket, yes, include the endpoint. And so far, domain is from negative infinity, comma, 2, because in 2 we have a hole, no include 2, no, union from 2 to 3, include 3, because in 3 we have a circle closed, no? To say it's defined. And the hole is undefined, and the other circle gets full or closed, it's defined. We have a gap in between 3 and 4. We have no domain in between 3 and 4, nothing. And we start again the last part of the projection. Look at that in green color. Projection, you projecting onto the x-axis. It's like that. It says parentheses from 4 to infinity positive. This is infinity positive, this is infinity negative. Okay, this is the final answer union. We have 3 intervals. The first one is this. The second is this. And the third is parentheses 4, comma, infinity. Is this. This is the domain. Of course, in the test, I don't want to put a complicated example. I only put the curve. Maybe we have a hole or no, And you're projecting onto the x-axis. You can see more elementary example in the review package. Okay, now the range. Well, the range is exactly the same idea, but you're projecting now onto the y-axis, not the x-axis domain. Let me using another color of the projection. I like this rainbow color. When you're projecting any point, bam, 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 but onto the y-axis, you can see something like that. Look, you can see here projection because this continues forever in the negative part. However, here in one is a hole again, undefined. And here we continue to 2. In 2, no. In 2 is bracket. In 2 is bracket because it's defined. And we have no curve. We have no 0, no curve, and 3, 4, 5, 6, 7. So the range is defined only in this interval. And this interval gets from negative infinity. Look, this is negative infinity. Look, negative infinity to 1. No include 1, because in 1 we have a hole. Hey, noise, please putting off microphone. Union, aye. 1, 2, 2. And 2 is bracket. And 2 is bracket. Please, off microphone. Toscano, Miss Toscano. Okay. Thank you. Guys, unfortunately, what will happen? So the next time we are discussing transformation. The transformation is very, very complicated. This is the most complicated moment in calling algebra. Okay. Entonces now I